Hi, this is Maggie. In this video we're going to answer the question, what are hexadecimal numbers? If you haven't already watched the video that answers the question, what is a number base, I suggest you watch that video first and then return here. Hexadecimal numbers, or hex numbers, are numbers in the base 16 number system. This means that there are 16 digits to count with, 0 through 9, and then we've run out of familiar digits, so we use A through F as the digits for 10 through 15. It also means that the positions in the place value number system for hexadecimal numbers are the 16 to the 0th position, or 1s, the 16 to the 1st position, or 16s, the 16 to the 2nd position, or 256s, the 16 to the 3rd position, or 4096s, and then the positions get quite large. The 65,536s position, the 1,048,576s position, and so on. You've probably seen hexadecimal numbers before. For example, when you choose a color in a graphics application, you might see a hexadecimal representation of the red, green, and blue values of the color, such as FF0000 or red. When we see a hex number, it is sometimes preceded by a pound sign. In Python, you might see a hex value prepended by 0x. When we count in the hex number system, we begin in the 16 to the 0th position, or 1's position, just as we do in base 10, base 2, or any other base. And we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, and then we have run out of digits. So just as we do in base 10, we add 1 to the digit in the next position. In this case, the 16th position, and reset the current position to 0. So after we count F in the 1's position, we add 1 to the 16th position and reset the F in the 1's position to 0. That number, 10, is 16 in base 16, a 1 in the 16th position and a 0 in the 1's position. Take a moment to compare that to the equivalent counting situation in base 10. We reach the last digit in base 10, which is 9, so we put a 0 in the 1's position, and we add 1 to the digit in the 10's position, giving us 10 or 10. If you have learned about the binary number system, compare it to counting in base 2 as well. The more you understand why number representation works the way it does in a number base, the easier it will be to recognize numbers, convert between bases, and make inferences about number representations. We can resume counting in the 1's position, giving us 1, 1, or 17, a 1 in the 16's position, and a 1 in the 1's position, and we can continue to count until 1F, or 31. Now if we want to continue counting, we have run out of digits again. So we reset the 1's position to 0 and add 1 to the 16's position, giving us 20 or 32. We can keep counting until we reach FF, an F in the 16's position and an F in the 1's position, or F times 16 plus F, or 15 times 16 plus 15, or 255. Now to continue, we must reset both of these positions to 0 and put a 1 in the next position, the 256's position, and again we can continue counting with a 1 in the 1's position, giving us 101 or 257. This table shows you the binary, decimal, and hexadecimal numbers up to 15. You might notice that the base 16 numbers are very compact compared to the base 2 numbers. Try answering some questions and solving some problems, maybe talk them through with some friends, and when counting in the hex number system and reading hex numbers makes perfect sense to you, you're ready to move on.